Hey there guys, Juan Santos here at the Electrical Apprenticeship School. Going to be solving a problem for the apprentices here at the school, and we're covering DC circuitry. And anytime you're solving for DC circuitry type problems, there's a couple of things you need to know. First thing you need to know is you got to know a little bit of Ohm's law. You got to have Ohm's law, and the other thing is that you have to know is you have to know the rules that govern basic circuitry. Okay. And what I have here on the board is a simple series circuit with simple values in them. We got a power source of 30 volts. Our first resistor is 60 ohms. We don't have a value to our second resistor, but we do know what the voltage drop is at our second resistor, and it's 10 volts. And our third resistor is 20 ohms. So what I did here, I set everything up first, kind of like in rows and columns. Got all my total values here: total voltage, total current, total resistance, and total power. And I did the same thing for each one of the components. Okay? Now, and what I did down here also, I went ahead and wrote down the rules that govern a series circuit. In a series circuit, total voltage is equal to the sum of the voltage drops. The same thing goes with total resistance is equal to the sum of the values of the resistor. However, when it comes to current in a series circuit is equal throughout the circuit because there's no alternate path. The same current that flows through R1 has to be the same current that flows through 2 and 3. That's why the rule for current is IT is equal to I1 is equal to I2 is equal to I3 and so forth. And the same thing goes with total power. Total power is the sum of the individual powers that are dissipated by each of the components. Okay, so these are the rules that govern how a series circuit works. And up here at the top, I wrote down the two laws. I wrote down Ohm's law and Watt's law. Okay, Watt's law states that the voltage is equal to the current times the resistance. And if we wanted to find the current, it would be just the voltage divided by the resistance. And vice versa for resistance. And the same thing over here for power. Power is equal to the current times the voltage. So if we know these two laws, and we know the rules that govern the series circuits, we can start filling out this table. But first thing we're going to do is fill out the table with what we already know. We know that we have 30 volts total. We also know that the value for the first resistor is 60 ohms. We know that the value for the second resistor as far as voltage is 10 volts. And we know that the value for the third resistor is 20 ohms. Okay? So this table kind of helps us to fill out the rest of it. In order to be able to solve for one of the values that's missing, you got to have two of the values, okay, based on the law. But what we can also do is use the rules to help us solve, the rest of the values that we're missing. I'll give you for an example. We know that the total voltage is equal to E1 plus E2 plus E3. Well, if I know that my total voltage is 30, and I know that I have 10 volts at E2, that tells me that the voltage at 1 and 3 is equal to 30 minus 10. So the voltage drop across 1 and 3 is going to be equal to 20 volts. The other thing I know as well is I have resistance 1 and 3 as well. So I know that resistor 1 and 3, based on this rule, they just add up, is equal to 80 ohms, 60 plus 20. So if I have E13 and R13, based on Ohm's law now, I can solve for I13, which is then the voltage divided by the resistance. In this case, 20 volts divided by 80 gives me 0.25 amps. Okay, so that's the current across 1 and 3, and the rule for current is it stays the same throughout all the components. So my total current is 0.25, I1 is 0.25, I2 is 0.25, and I3 is 0.25. Okay, the rules that govern the circuitry go across, and Ohm's law and Watt's law, the laws go up and down. Now I have 2 in every one of these columns, and I can start solving for the other unknowns. For example, if I want to find the voltage drop at 1, it's just the resistance times the current, right? R times I gives me E. So 60 ohms times 0.25 gives me 15 volts. Okay? All right. I can solve E3 2 ways now. I can do R times I to get E3, or based on the rule that governs the circuit, I can use this rule and say, okay, well, if I have 30 volts here, I have 15 here and 10 there, these two together gives me 25. 30 minus 25 is what? 5 volts. If you want to double check yourself, 20 ohms times 0.25 gives you what? 5 volts. Okay? So once you have the rows figured out and you have 2 in each column, it becomes quite simple to be able to solve. Let's do this one right here. Let's do RT. R is E divided by I. So 30 divided by 0.25 is 120 ohms. Okay? If I have 120 ohms total, and I have 60 ohms here and 20 ohms here, so I have a total resistance between 1 and 3 of 80. 120 minus 80 gives me what? 40 ohms, correct? Well, do it this way. 10 volts divided by 0.25 is 40. Okay? So there's more than one way to be able to solve for these values. If you know your Ohm's law, and you know the rules that govern the circuitry, you can start finding all the unknown values. Let's do power now. Okay, power, I times E. Okay, so it's just the voltage times the current to find total power. So in this case, 30 times 0.25, I have a total wattage of 7.5 watts. Okay, and I can do the same thing here. 15 times 0.25, 3.75 watts. Same thing here for P2, 10 times 0.25, 2.5 watts. Okay, now finding this last one, we can do two things. We can take these two values and subtract it from 7.5 based on this rule that governs the circuit, or we can also solve it this way, E times I, coming straight down the column. So we'll do it both ways. So 7.5 minus 3.75 minus 2.5 gives me 1.25 watts. Well, if I do 5 times 0.25, that's also 1.25 watts. So setting up a problem like this with rows and columns, and keeping these rules going across, and using Ohm's law to be able to solve the columns, makes solving basic circuitry kind of simple. Okay, and it's not difficult to do. It just takes a little bit of practice. So hopefully this video is informative. Hopefully you guys like the video. If you do like it, give it a thumbs up. Subscribe to the channel if you like. And besides that, This is how you solve basic circuitry using Ohm's law and using the rules that govern the circuitry in DC circuits, okay?